Welcome back to 9.3 activity 3, where we're testing dependent samples. We were looking at the example of husbands and wives, and if the husband is generally taller than his wife, and we found out with our hypothesis testing using the traditional way that yes, in general, it seems to be that the husband is taller than the wife. So let's go ahead and see if we could do it the p-value way. We'd set up things very much the same, except, so let's go ahead and just set up our hypotheses. Since we're dealing with paired data, our null hypothesis is that the average difference is 0. And because we did husband minus wife, we're going to check to see if the average difference is greater than 0. And remember that our level of significance was 0.05. So if we wanted to do the p-value method, we need the test statistic, t, which turns out to be, well, what we're going to do is we're going to get him from the calculator. So let's remember, let's see if we can get that to show up a little better. You can see that I've got my data in list 1, list 2, and list 3. Okay, and list 3 was the difference data. So we're going to do a stats t-test on just list 3. Okay, we think that the mu naught is 0. We're going to use list 3 because that was the difference data, and we want to see if the average difference is greater than the number mu naught of 0, so greater than, and let's calculate. And you'll see that our test statistic t equals 6.84, and our p-value is equal to 4.01. Now, I just made a common mistake that I don't want anybody to do. So notice this guy. The p-value is the probability value, so it can never be larger than 1. So if you see something like 4.01, keep reading your number. Oh, so that means times 10 to the negative 6. This thing is so tiny that we had to write him in scientific notation. So in other words, this means 0.1, 2, 3, 4, 5 zeros, and then I can start writing my number. So that p-value is super tiny. So if we do our test, we still need the test statistic, which is almost identical to what we did by hand, different only by rounding error. Okay. And if we take our p-value, which is teeny tiny, and compare it against the alpha of 0.05, we see that our p-value is less than alpha, and if the p is low, we reject the null. So reject the null hypothesis. So there is enough evidence to conclude that generally, or on average, depending on how you want to say it, the husband is taller than his wife. Okay. All right. So that's how we can do a hypothesis test, both traditional way and p-value way. We can also do a confidence interval. So I gathered some data here on the air quality in Salt Lake City versus Orem, Utah. And to make it a somewhat fair comparison, I gathered it for the same days in the year of last year, 2019. And the AQI is the air quality index, and the lower the score, the cleaner the air, the higher the score, the more crummy the air is. And people like me with allergies can have issues when the air quality is really bad. So we want to find a 95% confidence interval for the mean difference in air quality for the two cities, and then interpret our results in real world terms. So first off, let's do a requirement check. Was the data paired? And the answer is yes. The link is they are the measurements for the same day. So we measured the air quality in Salt Lake on the same day that we did in Orem. So they're paired by the day. And we also had a random sample. Okay. And it told us that the data seems to be normally distributed. Okay. So let's write down our information. Let's let sample one. Again, you can choose whichever you like. I'm going to go with the air quality index in Salt Lake City. And sample two, I'm going to do the air quality index in Orem. Okay. So we'll next need to put our data in our calculator. So I'm going to pause the video while you do that. Okay. So I've got the air quality index data in list 1 and the Orem air quality index data in list 2. Once again, I'm going to come up here and do on the L3 icon, Salt Lake minus Orem. So you can see that on the first day, Orem's was 7 higher than Salt Lake's, but on the second day that was selected, Salt Lake was 3 higher than Orem. Okay. So next up, we need to find XD bar, the average difference and the standard deviation of the differences. Since the differences were in list 3, I'm going to do a 1-bar stats on list 3, finding out that the average difference is 1.375 with a sample standard deviation of 5.37. And we had N was 8 pairs of data, which tells me we'll need 7 degrees of freedom. And if we're 95% confident, that means we're going to have between the two tails 5% chance of error, and confidence intervals are always two-tailed. Okay, so if we are 95% confident, you notice that that means we have 5% in two tails. So, and we had 7 degrees of freedom. So if we come down this column to the 7 degrees of freedom row, our critical value is 2.365. Okay, so our best guess is that the average difference between Salt Lake and Orem is 1.375, but that might not be exact. So we're going to give ourselves a little bit of margin of error. So we're going to take this critical value, t sub alpha over 2. We're going to times by the sample standard deviation over the square root of n, and that will give us our margin of error. So 2.365 times our sample standard deviation of 5.37 divided by the square root of 8. And let me slide that on there. So our margin of error should be 4.49. So what I want to do is pause the video and have you compute the confidence interval, knowing now our center and our margin of error, and then we'll come back and interpret him together here in just a second. Okay, so hopefully you put that together here. We did our sample mean minus the margin of error and sample mean plus margin of error. And I get negative 3.115 less than mu sub d. The population average difference is less than 5.865. So we interpret that saying we are 95% confident that the population average difference in air quality index of Salt Lake City and Orem is between negative 3.115 and 5.865. Okay. Now let's go ahead and we're going to leave a little bit of space here to do one more interpretation here. But let's go ahead and see if the calculator could have helped us along the way. Let me slide this up a little bit. Remembering that we had our differences in list 3 here. Okay, let's go over, and since we had a random sample and it was normally distributed, we can use the t distribution. So let me do a t interval on the data in list 3. And since we don't have group data, everybody counts once, and our confidence level was 95%. Let's write this down here. So we're going to run the t-interval command, and we get negative 3.115, comma, 5.865, which coincidentally is what we got by hand. So we will now write the same thing. We are 95% confident that the population average difference in air quality index between Salt Lake, since we chose Salt Lake first, and Orem, Utah, is between negative 3.115 and 5.865. Now, if we are careful here, you'll notice that the air quality index can never be negative. What we're talking about here is the difference in air quality index. So if we were to take a look at our number line here, if the difference, sample 1 minus sample 2, is here, so mu1 minus mu2, that tells me that mu2 is higher than mu1. But like we saw earlier in the chapter, if mu1 minus mu2 is a positive number, that tells me that mu1 must have been bigger than mu2. Okay, so if our confidence interval is on both sides of 0, like it is here, when we do our second part to our conclusion here, we say that because the confidence interval lies on both sides of 0, we cannot tell whether the AQI is higher in Salt Lake or Orem. Okay. So this would say right here that the Orem AQI is higher, meaning worse air. This would say that the AQI in Salt Lake is higher, meaning worse air in Salt Lake, but the true value, the true difference could be here or it could be here, so it's too close to call. Right now, all we can say is that it's too close to call, that we can't tell whether the air quality index is higher in Salt Lake or Orem. If the air quality index interval had been all on this side, that would mean that mu1 is greater than mu2. So we could then say that the air quality index in Salt Lake is higher than the air quality index of Orem, or vice versa if it was all over here, all on one side of 0. Hope that's made sense. Go ahead and do the other 2 problems and submit it.